All right, I'm Malachi Greb, CEO of Elite Automation, and here we're at the Fanuc booth at MODEX with LP, the Director of Engineering for Fanuc. Thank you for joining us today.
Hey, thank you so much.
It's an honor.
So this is a vertical ASRS. Basically, we can store stuff away and retrieve it as needed. And quite common in the warehousing industry to have shelf restocking of everything, and that's what it does. When things come in, we stock them away, and when an order is placed, it will retrieve that particular order. And that's what we're showing here. An order is retrieved, and since it's a trade show, we put them in a bin and we put them back. We restock it immediately.
Picking and placing it right back, right?
Right.
Yeah, so one thing that I think is really cool about this system is you're seeing this being like an inventorying type of system, but this same CNC gantry style system, or I'll say a gantry style robotic system, can also be used for other things like palletization and a lot of other use cases. I don't think we see Fanuc enough in the like robotic gantry sector, especially utilizing servos in these very creative ways. And I think this is a very good product to have on the market.
Right. So one unique thing that we're showing here is, if you see, for this XY motion, the motors are stationary. So the motors aren't moving, which makes it very high speed.
Yeah.
So we're showing here 1.5 meters a second zipping around. It can be even faster based on sizing the motor and the gear train.
So, gotcha. Yeah. And so this system here is actually not driven by the Fanuc robot, right?
Correct. So this system is driven by the Fanuc Power Motion. This is the controller and the amplifier that are controlling all the motors. And this whole thing is connected to the robot controller through robot on-site. Just that one Ethernet cable connecting the two.
Gotcha. So is it communicating over Ethernet protocol, or is it a special protocol?
Over Ethernet.
Over Ethernet?
Yeah.
Okay, very good.
The protocol, we call it robot on-site.
Robot on-site? Okay.
Yeah. Connecting the Fanuc CNC to a Fanuc robot controller.
Very nice, very nice. And so for like the Fanuc CNC stuff, is the like programming of the motion is all done in the CNC side?
Yes. So you can see the G code. There are many ways to program it. You can use the CNC guide. So this is one of the ways.
Wow, awesome. And I was talking with somebody yesterday as well, and they said one thing that you can do is you can actually do some of the programming on the robot side and just have it command the CNC positions.
Right. Yeah.
So I think that's like a cool, unique way for, like, let's say for instance we had a customer and the customer's not familiar with the CNC side, but they're familiar with the Fanuc robot.
Yeah.
We can then give them a system that's developed in a way that they don't have to worry about the CNC side, right? They can just have the robot command the CNC positions for the gantry side of the system.
Yeah. So basically the programming can be made simpler for them. That way they don't have to worry about the programming themselves.
Yeah.
Behind the scenes, it already happened.
This has already happened. Yeah, right. Absolutely.
Right.
Absolutely.
So one more thing that I want to point out is the one marker offset. Now at the back green arrow. So this robot does not have to be sitting right next to this machine, right? That can be moved around, plugged back into the 110, turn it back on. And then first time, you go get the one marker offset, and it knows where the machine is, it knows what to do.
Yeah,
so
absolutely.
The same program can be used over and over again, just using the one marker offset.
Yeah, and so like what he's saying there is, like, you don't have to even mechanically attach this unit to this unit. You can actually place this in a maybe maintenance accidentally places it a little bit crooked. It's going to go in there, it's going to take a picture of that offset, and it's going to adjust all of its positions in accordance to that offset marker, so that way it picks appropriately every single time, and that setup time is completely removed. And I think something like this is very, very important, especially on collaborative, because a lot of collaborative applications, they want to take that robot and move it to other lines, and one of the reasons why that's not feasible is because the setup time. It takes time to reteach the robot's positions, but if you have each station set up with one of these one marker offsets, there you go. Just set it, have it locate the marker, and you're ready to run.
Right. So using that method, the cost goes down significantly. You don't have to have an AMR that the robot sits on.
Yeah.
You can just have just the dolly that you move around, just lock it in place, you're good to go.
Awesome.
Yeah. And a couple of more things. The power motion controller is also controlling the conveyors, the elevators, and everything.
Yeah.
So
all servo driven.
Yeah, 100% servo driven.
Yeah. So like another thing that's really cool and unique about this, and with the servos, especially with like conveyors and stuff, technically you can track exactly where that box is at on that conveyor at all times. So if you wanted this robot to pick while the conveyor is still in motion, you're able to do that. You're getting direct feedback to know exactly where each product is on the conveyor after it's been placed there. So it's just good to have these type of feedbacks for applications that need it.
So one more thing is, this whole thing, we talked about it earlier, but I just want to repeat it. The whole thing can be scaled up or scaled down. This is just a scaled down model, just showing the capability.
Yeah. So anything you can put a Fanuc motor on, we can do this with, right?
Right.
Awesome. Thank you, LP.
Thank
I
you so
appreciate
much.
you, sir.
Really appreciate it.